Few endeavours have captivated humanity as much as venturing into space. And in 1961, for the very first time, Yuri Gagarin did just that. But we didn't stop there. Following that launch, both the USSR and United States set their sights on the moon, and the space race was in full swing. What followed was one of the largest technological undertakings in history. The Apollo program employed nearly 500,000 people and cost over 2.5% of US GDP annually over a decade. NASA's Saturn V rocket was one of the most powerful rockets ever built, and just 8 years after the start of the program, it helped land the first men on the moon. The future of space was bright. Humanity as a spacefaring civilization seemed inevitable. Before long, manned missions to Mars were being planned, as was the development of a low-cost, reusable space shuttle that would fly every month. Space travel wasn't an impossible dream, it would be a regular occurrence. Except none of that came to pass. The manned Mars missions were scrapped, and the low-cost space shuttle was anything but. After multiple design compromises and refurbishment difficulties, shuttle's payload to orbit ended up being more expensive than Saturn V. While a space shuttle is remembered as an iconic spacecraft that accomplished many successful missions, it also serves as a stark reminder that space is hard and very, very expensive. In fact, adjusted for inflation, the shuttle cost nearly $30,000 for every kilogram launched into low Earth orbit. At this price tag, it's no surprise that despite many optimistic predictions, our spacefaring future never really materialized. While planet hopping remains a staple of cinema, there is no base on the moon or colonies on Mars. Progress in space has remained fairly stagnant, or at least it has until recently. Over the last decade, progress has started to accelerate, and now there's a new rocket called Starship on the horizon. And it seems like things may be about to change very quickly. For the majority of the space shuttle era, entirely private enterprises launching humans into orbit looked like a distant dream. But in May last year, SpaceX did just that. And it's only one in an impressive line of achievements for the company. Founded in 2002, SpaceX was the result of Elon Musk's earlier project to send a greenhouse to Mars using a large intercontinental ballistic missile purchased from Russia. No, I'm not making that up. After the vodka-fueled deals fell through, Elon had no affordable launch options remaining and decided to build his own rocket enterprise instead. As you might suspect, a company that was formed on the back of a radical idea. It has maintained some of that thinking as a core part of its DNA, and the results have been, well, astonishing. SpaceX's debut rocket, Falcon 1, was the first private liquid-fueled rocket to go into orbit, and that was just the beginning of the records. Their primary launch vehicle, Falcon 9, has been tremendously successful, ferrying cargo and even people to the International Space Station, and launching satellites to orbit at a previously unimaginable rate and cost. And after decades of films about space, Falcon will be facilitating the first movie to actually film in space. But perhaps Falcon's greatest achievement is something that many in the industry thought couldn't work economically: reusable rockets. It certainly wasn't easy. But in late 2015, it finally paid off, with a successful booster landing at LZ-1, and soon they were doing it at sea on their drone ship called Of Course I Still Love You. And since then, it's become, well, routine. Its reusability has made the cheapest high payload rocket even cheaper. But SpaceX didn't stop there. What if you need to get more than 23 tons into orbit? After a difficult development phase, and 5 years later than planned, Falcon Heavy arrived to do just that. It more than doubled Falcon 9's payload capacity to 57 tons. And of course, they managed to land all of those boosters too. Well, sometimes. SpaceX isn't the only company revolutionizing space. There are many more exciting projects that we will look at in future videos, but it's fair to say that SpaceX is leading the revolution of the launch industry, both in terms of cost and launch cadence. Thanks to SpaceX, getting into orbit and beyond has never been easier. With their significant cost and technological advantage, by 2018, they already had a 65% share of the commercial launch market. Many companies would have stopped there and instead focused on maximizing Falcon's capabilities and cost efficiency, but not SpaceX. In fact, they're already well on their way to developing a brand new rocket, and this idea is perhaps their craziest yet. After many iterations, from the truly colossal ITS to a slightly more modest BFR, and now Starship, we finally have a pretty good idea of what SpaceX's new launch vehicle will look like and what it should be capable of, and the answer is pretty mind-boggling. Starship is capable of launching 20 tons to low Earth orbit, just under what an expendable Falcon 9 is capable of, but this is just as a standalone craft. Starship is really intended as a two-stage rocket, thanks to the addition of its super heavy booster. The fully stacked Starship is expected to have a payload capacity over 100 tons to LEO, with Elon Musk aiming for 150. That would make it amongst the highest payload rockets ever built. But it's not the sheer size and power that really sets it apart. After all, the Saturn V moon rocket could lift 150 tons to LEO. The difference, however, is that Starship is designed to be reusable. So does that mean Starship is really just a bigger Falcon rocket? Well, not so much. After all, Falcon isn't fully reusable. Like Starship, Falcon 9 is a two-stage rocket. But while a main booster is recovered, the upper stage is expended, eventually deorbiting to burn up on a controlled re-entry. As of June 2019, however, Falcon did gain the ability to reuse its fairings too. How does SpaceX rescue large unpowered fairings, you may wonder? In the most SpaceX way possible, of course, using a boat and a big net called Mr. Steven. Falcon's booster and fairing account for 60% and 10% of the rocket's build cost respectively, and refurbishment is claimed to be less than 10% of total vehicle cost. While exact cost figures for SpaceX aren't easy to come by, it's clear that Falcon's partial reusability saves a lot of money, and it has led to a reduction in launch prices for customers. However, for SpaceX, this is still too high of a cost for their ambitions, and while they also hold the record for the fastest reuse of a rocket at 38 days, for them, it's not fast enough. Their recent record for 8 flights of a single booster shows that Falcon 9 really has impressive reusability, but that's nothing compared to what SpaceX plans for Starship. Starship has been designed to be fully reusable from the start. Not just the super heavy booster, but the upper stage of Starship too. But more than that, it aims to be reusable without refurbishment. That's right, rather than a month or so turnaround, Starship is being designed to take off an hour after landing. This isn't just reusability, but rapid reusability. It requires a number of complex technologies, such as a robust, maintainable heat shield and landing legs. But these additions also come with a weight, and thus payload penalty. And here lies one of the key challenges of Starship. For every extra kilogram the super heavy booster weighs, a kilo of payload is lost. That penalty is especially severe for the upper stage, as every extra kilo of vehicle weight costs 5 kilos of payload. It's therefore easy to understand why SpaceX is testing some intriguing methods to remove every possible kilo dedicated to landing Starships. While reducing weight from a 130-ton rocket may sound easy, rocketry is extremely complex and requires a great deal of ingenuity to overcome. SpaceX have repeatedly demonstrated clever, even crazy solutions to weight saving. Starship is no exception. But that's something we'll look at in more detail in the next video. For now, all we need to understand is how difficult, yet vital, full reusability is for Starship's success. Elon Musk is often quoted as saying that he wants rockets to be like aeroplanes, not something you build and throw away, but fly to a destination, refuel, and fly back hundreds or thousands of times. This is a radical departure from the existing space industry, and the implications are massive. But you may still be wondering, why go to all this trouble? If Starship delivers even close to its design parameters, then it will be both the lowest cost and most capable rocket ever, by far. But what could it actually be used for? After all, SpaceX already has a big advantage over the competition in most launch segments. How much do they actually have to gain from an even better rocket? SpaceX already has more launch capacity than market demand. In fact, in 2020, SpaceX's largest customer was SpaceX. That's right, over half of Falcon 9 launches last year was for their own Starlink satellites. And Falcon Heavy is impressive, but it's only flown 2 commercial missions to date. And while there are some more planned in the future, it doesn't suggest there is a particularly large market for its heavy lift capabilities. So why spend so much time and money developing an even higher capacity rocket? The answer comes back to Elon Musk's ultimate mission for SpaceX: Mars. Elon founded SpaceX on the back of a plan to send a greenhouse to Mars, and getting humans to Mars has been a core ambition of SpaceX from the very beginning. That isn't to say it's their only objective, of course. SpaceX is a private company after all, but it does guide them towards taking big Mars-orientated development gambles. Risks on technologies that wouldn't otherwise make sense, given the strength of their current market position. In fact, it's fair to say that technology risks are generally the opposite of what has historically happened in the launch industry, where the goal is normally to keep using flight-proven hardware for new vehicles, even if it means using decades-old computer chips and engines. So while a super heavy rocket doesn't seem necessary to fulfill the existing launch market, it's absolutely essential if you're planning to build a city on Mars. And it's not just the sheer size. There are many more design parameters that seem over-engineered, but are critical for getting to the red planet. Traveling to another planet requires a lot of power to transport the crew, equipment, and supplies, and Starship's 100 tons to low Earth orbit still isn't enough. Escaping Earth's gravity well is extremely difficult, and a fully loaded Starship won't reach orbit with enough fuel to then reach Mars and land. Rather than reducing the payload to Mars, however, Starship is being developed to enable orbital refueling. This is another technology that isn't really needed for the current market, but is critical for Mars. To refuel, a variant of the Starship second stage is being purpose-built as a large fuel tank. With a Mars-bound Starship waiting in orbit, the refueling tanker will be sent multiple times to refill it, before the Mars ship sets off with a full tank. Orbital refueling of this nature has never been attempted before, and would be a major milestone for space travel. But there is another key new technology that is needed for Mars: methane rocket engines. Falcon's Merlin engines are excellent for getting into space, but for Starship there are 2 major problems. Merlin's kerosene engines produce soot during incomplete combustion, which leads to a lengthy refurbishment time. For orbital refueling to be viable, multiple Starship tanker trips need to happen in a relatively short space of time. Rather than build multiple tankers to achieve this, a rapidly reusable engine enables one tanker to make all those refueling trips in quick succession. The methane and liquid oxygen burns much cleaner, meaning that the Raptor engine doesn't need refurbishing after every flight. Methane is also very important so that you can actually bring people back from the red planet. To return, you have to produce your own fuel on the surface, and on Mars, kerosene is pretty hard to come by. For methane, Mars has all the ingredients it needs to make that happen via the Sabatier process, with carbon dioxide in the atmosphere and ground-based water ice. So while SpaceX's difficult and expensive technology switch might not have initially made sense, for them it's the only way. And they are making great progress, becoming the first to fly a methane rocket, but not quite to space yet. So if we factor all of Starship's capabilities together, what do we get? Despite its payload penalty from the extra weight of reusability, its base launch capacity is still comparable to Saturn V. But thanks to reusability and orbital refueling, its capacity and flexibility actually extends far beyond anything we've seen before. Whether it's putting large payloads on other celestial bodies, getting large arrays of equipment in orbit around gas giants, or simply getting across the solar system faster than ever, Starship intends to be the rocket to do it. But SpaceX's plans extend far beyond that. Not only do they want Starship to help build a moon base and a city on Mars, but they want to use it for mass satellite deployment, space tourism, and even Earth-to-Earth rapid transport. How viable these applications are is the topic of future videos. Still, we're getting ahead of ourselves. Firstly, how viable is Starship itself? After all, it's still in the early prototype phase. Many of the major design challenges are yet to be built or tested. How sure can we be that SpaceX can make it work? And if Falcon Heavy was 5 years late, when can we reasonably expect a commercially ready Starship? For now at least, we can see that its development is proving to be astonishingly fast by space industry standards, and SpaceX already have some pilot demonstrations of their radical reuse techniques, such as the successful attempt of their skydiving belly flop maneuver. Well, mostly successful. Starship has many more seemingly crazy design decisions that we'll look at in part 2 of this video series. From developing the next generation of rocket outdoors, to abandoning the lightweight carbon fiber construction in favour of much heavier stainless steel. As we'll see, what makes SpaceX's approach to Starship so interesting is more than just extreme design decisions, but rather their unique approach to the development process itself, and how it's changing the shape of the rocket industry. So, how is SpaceX planning to fund this new rocket? What allows them to move so quickly? And why was a prototype for the most advanced rocket in the world built in a field with the help of a water tower company? Let's find out.